Good morning students, welcome to session 4 on numerical analysis. So that is on errors. In this today's session, let us study some more examples on errors. Let us take first example. If 0.2222 and 0.5714 are approximate values of two numbers 2 by 9 and 4 by 7 respectively, then find absolute and relative error in their sums. In the last session we studied about the error in sum, error in difference, error in product and error in quotient of two numbers. So using those formulas we can solve these examples here. So these are approximate values. Let us take this one as here. Exact numbers are 2 by 9 and 4 by 7 and the approximate values are given here like this. So x is equals to 2 by 9. This is exact number and its approximate number is 0.2222 and exact number is another exact number is 4 by 7 and its approximate number is 0.5714. So now absolute error. We know absolute error is less than or equals to mod of x minus xa plus y minus ya. That is absolute error in the sum here. So is equals to like this here. Absolute error in sum is less than or equals to, this is absolute error in sum, that is here ES. Absolute error in sum mod of ES is equals to like this here, which is less than or equals to here 2 by 9 minus 0.4 times of 2 plus 4 by 7 minus 0.5714. So which is less than or equals to here. What to do is here, you have to divide 2 by 9 in calculator. 2 by 9 minus 0.2222. If you simplify this, you will get 0.4 times of 0 to 2. Using scientific calculator, you have to solve this one here. Plus 4 by 7 minus 0.5714 is, after simplification, you will get here 0.4 times 0 to 8. For this, you have to use calculator for dividing and all these things. So which is less than or equals to, add these two, which is less than or equals to 0.4 times of 0, then 5. So and also relative error. Relative error is equals to, we know here, absolute error divided by mod of x plus y. This relation we studied in previous sessions. So that is ER is equals to mod of EA divided by mod of x plus y. We know this relative error. We know this one here. Relative error is equals to absolute error. That is EA divided by mod of x plus y, two numbers it is. So it is equal to like this here. So absolute error is here given as here 0.4 times of 0.5 divided by mod of x is 2 by 9 plus 4 by 7. So take LCM here is 9 7s is 63. So cross multiply and simplify, will get here. This is 50 divided by 63. Take reciprocal of this one and divide it by 50. Using calculator only you have to solve this one, because in the exam also you are going to allow to use calculator. So this is 0.4 times of 0, 63, which is equals to, we can write here 0.63 into 10 raised to minus 4. So 10 raised to minus 4 means you have to go back 4 digits back or left side from this from this point here. This is 1, 2, 3, 4. If you come here, then you have to write 10 raised to minus 4. 0.63 into 10 raised to minus 4. Let us take one more example. Find the difference under root of 3.28 minus under root of 3.27 and evaluate the relative error of this difference. So here let us take x equals to 3.28, which is equals to, using calculator only how to find this one, square root of 3.28, it is equals to 1.18110770276. So it is equals to, we can take here approximate, we can take here 1.811. I told you how to make the round of this number here. So we want only 4 digits, means after decimal point we want 4 digits, means you have to see the next digit here. Next digit is 0, we can neglect this one here. So y is equals to under root of 3.27, it is equals to 1.8083. Again after 3 we have 1. So if this is less than 5, we can neglect this directly as it is. So it is equals to 1.808. We can take 3 also. So now maximum error in x and y is equals to, we know here maximum error is less than or equals to 1 by 2 into 10 raised to minus 3. How it is minus 3 means here So in this number, you have to take here absolute error is less than or equal to 10, 1 by 2 10 raised to m minus n minus 1. Last digit you have to see here. So last digit is here. Last digit is 10 raised to minus 3. We know this. How to express this one in this one is here, it is 1 into 10 raised to 0 plus 8 into 10 raised to minus 1 plus 1 into 10 raised to minus 2, because here after decimal point you take negative symbols, plus 1 into 10 raised to minus 3. So this one you have to take here. Here also we have after decimal point we have 3 digits, so it is also 10 raised to minus 3 only. So it is equals to 1 by 2 into 10 raised to minus 3. So 1 by 2 is 0.5 into 10 raised to minus 3. So 10 raised to minus 3 means you have to go on left side 3 decimal places. That is here, if it is like this here, 0.5 into 10 raised to minus 3 means here this is 0.5, no, this is 5. You have to go back 3 digits here, 1, 2, 3. This is 0.0005 it is. So error in x is, this is both error in x and y, because both the terms contains last digit is 10 raised to minus 3. So error in x is 0.0005 and error in y is also 0.0005. So therefore the maximum relative error is equals to mod ex plus mod ey divided by mod of x minus y. So it is equals to 0.0005 plus 0.0005 divided by 0.003. The difference of x and y here, it is equals to 0.003. So after adding these two, we will get here 0.001 divided by 0.003. Here both the terms are same. So these two get cancelled. It is 1 by 3. 1 by 3 equals to, we know, 0.33333 also. So it is again non-recursive. So we will get 3 only. We can take here only up to 4 decimal places. Let us take one more example. Find the product of 137.2 and 372.5 and so here and state how many figures of the product are trustworthy, given that the number of numbers are correct to 4 decimal places. So let us take here x is equals to given numbers. X is 137.2 and y is 372.5. Therefore the absolute error in the two numbers. The absolute error in two numbers is less than or equals to 1 by 2 into 10 raised to minus 1. So it is, why it is 10 raised to minus 1 means here last digit here is, it is after decimal point it is 1 digit, no, it is 10 raised to minus 1. So just now in the previous example I told you here x is 137.2, no, it can be written as here 1 into 10 raised to 2 plus 3 into 10 raised to 1 plus 7 into 10 raised to 0 plus 2 into 10 raised to minus 1. So this is 10 raised to minus 1. So it is 1 by 2 into 10 raised to minus 1. So 1 by 2 into 10 raised to minus 1 is 0.1, that is 1 by 2 is 0.5 into 0.1, it is equals to 0.05. So error in x and error in y is less than or equals to 0.05. So now their product x into y is equals to 511.7 it is, 51107 it is, because here after multiplication you will get here this is 10, so it is 0. Now relative error is equals to, we know relative error is approximately equals to error in x divided by x plus error in y divided by y. It is error in the product here. Error in the product is equals to approximately error in x divided by x plus error in y divided by y. This formula we studied in the last session. So there you can find this formula. Error in the product of two numbers is error in x divided by x plus error in y divided by y. So it is 0.05 divided by 137.2 plus error in y is 0.05 divided by 372.5. So divide this one using calculator. You will get here these two digits. So after adding these two, you will get this is equals to 0.0004986,596. So this for all these calculations you have to use the calculator only. So relative error here is approximately less than or equals to, it is 0.0004986,596. Now the absolute error in product, that is mod of EP is equals to error in relative error into x into y. So which is less than or equals to here relative error just now we have done here into x into y, product of x and y we have done, it is also 51107 it is. So error in absolute error in product is less than or equals to, after multiplication of these two it is 25.485. So we know here if you remove this mod, if mod z is less than or equals to less than a, then this implies here z is greater than minus a less than plus a. So it is equals to here, if you remove this mod, you will get here error in product is less than greater than or equals to minus 25.485 and it is less than or equals to 25.485. So this is error in product is between these two numbers. Therefore, the actual value of the product lies between here. So this is here what here 5. This one error in product is product of two numbers is 51107 minus 25.485 and 51107 plus this one 25.485. So that is it lies between here. Add these two, difference of these two is 51081.515 and if you add these two you will get here 51132.485 and the mean of these two is add these two and divided by 2 we will get here 51.107 into 10 raised to minus 3. So this is about this result here. So this is the mean value of these two. Let us take one more example. Find the relative error in the calculation of 2.087 divided by 0.133 where the numbers 2.087 and 0.133 are correct to 3 decimal places. Now determine the smallest interval in which the result holds. Let us take here the x1. First value is x1 here 2.087 and x2 is 0.133. So now the maximum error in their numbers is delta x1. Delta x1 is again 1 by 2 to 10 raised to minus 3. Why it is 10 raised to minus 3 means here last digit is 10 raised to minus 3 here. And delta x2 is again it is also same 1 by 2 into 10 raised to minus 3 because it also has 3 digits after decimal point. So delta x1 is here 1 by 2 is point. This is 1 by 2 is how much here? 1 by 2 is 0. So here delta x1 is equals to 1 by 2. 1 by 2 is 0.5 into 10 raised to minus 3. 10 raised to minus 3 here is we can write as it is 10 raised to minus 3. That is here to take 3 decimal places back direction. This is 5 it is 5. 1, 2, 3 it is 0.0005 it is like this here. Similarly delta 2 is also same 0.0005. So thus the relative error in the given in the quotient of two numbers x1 and x2 is here relative error is less than or equals to delta x1 divided by x1 plus delta x2 divided by x2. So it is equals to 0.0005 divided by 2.087 plus 0.0005 divided by 0.133. So these two are the relative error in this is the errors in both the numbers here. So take 0.0005 as common. So it is equals to, the simplification is like this here, 0.0005 is you have to take in common here. It is 1 divided by 2.087 plus 1 divided by 0.133. So here take LCM. So LCM is 2.087 and 0.133. Now product of these two. So cross multiply it is 0.133 plus 2.087 divided by product of these two. So it is equals to relative error is less than or equals to here. Less than or equals to 0.0005 into add these two numbers here. Add these two numbers and adding these two numbers and the product of these two numbers, divide these and multiply with 0.0005. After simplification you will get here 0.003998 and it is approximately equals to, we can take here 0.004. Take this one as equation number 1. So now the absolute error in quotient is, absolute error EA is approximately equals to here relative error into x1 divided by x2. So which is less than or equals to point here 0.004 into x1 is 2.087 divided by 0.133 and it is equals to here 0.0628. So therefore the true value of the quotient is 2.087 divided by 0.133 lies between here. Again this is the same here, 2.087 divided by 0.133 minus error in absolute error EA and it is plus absolute error EA. That is here. So here it is 15.6717 minus this value here, because after dividing these two you will get here 15.6917 minus 0.0628 and 15.6917. So this is the division of these two plus this error here, absolute error, that is 0.0628. So after simplification you will get these two numbers. So thus the required interval is in between 15.6289, 15.7545. Let us take one more example. Find the number of trustworthy figures in 0.318 whole raised to 3, assuming that 0.318 correct to the last figure. So here x is equals to 0.318 and number of this is power here. It is in the form of x raised to n. We studied here in the last class here. Number of trustworthy figure in x raised to n. Here n is how much? 3. So therefore the absolute error in x is less than or equals to 1 by 2 into 10 raised to minus 3. Again it is 10 raised to minus 3 I told you here. So this one here last digit is 10 raised to minus 3 it is. So it is again 1 by 2 is point. This is 1 by 2 is how much here? 1 by 2 is 0.5 into 10 raised to minus 3 it is 0.0005. So the relative error in x raised to n is relative error is less than n into mod of ex divided by x. This formula you studied in last session. So it is equals to 3 into error in x is here given 0.0005 divided by x. X is the given number. So given number is here 0.318. So dividing this and after simplification you will get here 0.00472. So therefore the the absolute error in x raised to n is approximately equals to relative error into x raised to n. So relative error here is 0.00472 into x raised to n is 0.318 raised to 3 it is. So first you have to find 0.318 raised to 3. You will get like this. So multiply these two, you will get here 0.0000152. So thus the error affects the value of x raised to n from 4th decimal here. So because here we have only up to 3 decimal places it is 00. It starts affecting from 4th decimal place. Hence the number of trustworthy figures in the given number is 3. Only up to 3 decimal places it is correct. Then 4th decimal place is not correct. So therefore it is 0.318 whole raised to 3. Just we have done here 0.318 whole raised to 3 is 0.32157. So only up to 3 decimal places you have to take correct here. Next digit is not correct. So therefore you have to take only 3 decimal places, that is 0.32 here we have 0.32. 4th decimal place is not correct because here absolute error is starts from 4th decimal place. So you have to take only up to 3 decimal places. Take one more example in this. Find the number of trustworthy figures in 653 whole raised to 1 by 4, where 653 is the correct to 3 significant figures. This is exactly same as we have done in the previous example. So this is an assignment for you. You solve yourself this example and you can find the number of trustworthy figures in this and correct the figure up to 3 decimal places. So I hope you have I hope you will done this will do this example. If you find any difficulties you can ask me. So I will give you this notes. So if you find any difficulties you can ask me. This is exactly same as the previous example. Only the difference is here x is 653 and power is 1 by 4. So this is all about the today's session. Thank you.